right, guys, I've got two last slides in this set for Module 3. They are redundant with things that we've said before, but because land water heating contrast is part of those mechanisms of transferring heat energy across our planet, it needs to be said here. So I've said a number of times now, and I really don't mind repeating it. It's really important that you understand it, is that the molecular structure of different elements have different specific heat, and water has fantastic specific heat because of its hydrogen bonds, right? So the hydrogen bonds are able to accept a lot of solar energy, they hold on to that solar energy, and then they release it later. Sand, concrete, glass, granite, sandstone, mica schist, whatever the terrestrial component of the earth is, doesn't have the same volume of hydrogen bonds and therefore doesn't have the same storage capacity. So land is going to heat up fast and it's going to cool down really fast. And it's going to heat up a lot more and it's going to cool down a lot more. So the range of temperature variability is greater on land than it is in and around water. All right, so that's as the little diagram says, that's the special abilities of water, or the magic that water has. Combine that with the Coriolis effect, is now we can take that water which is storing heat energy, and we can move it to higher latitudes and infuse higher latitudes with that water. So this next slide is a nice diagram of the warm and cold currents. We can see all the red currents, which are warm. The arrows are pushing towards a pole and pushing towards a pole, and it's all on the East Coast. I have East Coast red lines and East Coast red lines, East Coast towards the pole, East Coast towards the pole. We then have cold currents on the West Coast towards the equator, West Coast towards the equator, West Coast towards the equator, and then West Coast towards the equator. We can't quite see the Indian Ocean happening over here. They haven't drawn it on the equivalent side here. But this is what we've got, all right? We see similar gyrations with the atmosphere. Now, ocean currents are limited to the container they're in, so the North Atlantic container or the North Pacific container or the South Pacific container is as far as water can move, but air can move across water and land with less restriction. It might get hung up a little bit on a mountain range, but eventually it gets pushed across the landscape. So that takes us to the end of Module 3. Please contact me if you are finding something a little bit sticky or muddy or confusing. I definitely want you to do well, and I definitely want you to get stuff ironed out as we move along, because these principles build upon each other, and I want you to be ready and prepared for the exams. All right, talk to you later. Bye.